Hello, welcome to our channel Learn to Score. In this video, I am going to explain you what does it mean by quadratic formula and how to derive quadratic formula, and also discuss about nature of roots for different values of discriminant of quadratic equation. This is from Quadratic Equations chapter of 10th class mathematics. I hope you like the video. Please subscribe to our channel for regular updates. Thank you. Let us learn about quadratic formula now. To do that, let us first find roots of ax square plus bx plus c equal to 0 using completing square method. In the previous video, we have learnt about how to find roots using completing square method, right? We are going to use that method now to find roots of ax square plus bx plus c equal to 0. For doing that, let us divide each term of the equation with a, so that I can write it as ax square by a plus b by ax plus c by a equal to 0, right? So when you simplify it, it can be written as x square plus b by a times x plus c by a equal to 0, right? Let me rearrange this equation and write it as x square plus b by a times x equal to minus c by a, right? What I have done is I have transposed this c by a to the other side of the equation such that I could write it as minus c by a on the other side, right? Now the objective here in the completing square method is that we have to find what to be added to both the sides of the equation such that left hand side part of the equation becomes complete square, right? Let's learn about that first. We know that p plus q whole square equal to p square plus 2 times pq plus q square, right? Let me transpose this plus q square to the other side so that I can write the equation as p square plus 2pq equal to p plus q whole square minus q square, right? Now look at this. Left hand side, I have x square plus b by a times x, right? I want to compare that with LHS of this particular equation, p square plus 2pq. When you compare this, what is p and what is q you want to find, right? By looking at this, it becomes a bit difficult to find out what is p and what is q. For that reason, what I'm going to do is I'm going to write x square plus b by a times x as x square plus 2 times b by 2a times x. What I have done, I have multiplied b by a with number 2 and divided that with number 2, right? So now you can compare x square plus 2 times b by 2a times x with p square plus 2pq. When you compare it, you say that p is x and q is b by 2a, right? Now let's write this equation, p square plus 2pq, right? That is p plus q whole square minus q square. Since we know what is p, that is x, and what is q, that is b by 2a, if you substitute these two into this particular equation, you would be writing the equation as x square plus b by a times x equal to x plus b by 2a whole square minus b by 2a whole square, right? Let's take a note of this. Now, if I transpose this minus b by 2a whole square to the other side, the equation is going to be x square plus b by a times x plus b by 2a whole square. That is equal to x plus b by 2a whole square, right? When you look at this, what you can say is, by adding b by 2a whole square to x square plus b by a x, we could transform that into complete square, right? Now look at this equation. I have x square plus b by a times x on one side and minus c by a on other side, right? Now I want to add b by 2a whole square to both the sides of the equation. When I do that, the equation now becomes x square plus b by a times x. This is written as is. Now I have added b by 2a whole square onto LHS, and I am adding b by 2a whole square onto RHS also. Now look at this. This is exactly equal to x plus b by 2a whole square, right? Let's write that. X plus b by 2a whole square equal to b by 2a whole square minus c by a, right? I have rearranged this such that I can write it as b by 2a whole square minus c by a. Now look at this. I can write this as b square divided by 4a square, right? B square divided by 4a square minus c by a. I want to simplify this now. When you want to simplify this, what you can do is look at the denominators 4a square and a, right? Their LCM is 4a square, right? Now b square times 1 is what you would be writing, minus c times 4a is something you write, right? For example, when you have something like 4a square, b square by 4a square minus c by a. So we said that LCM is 4a square, right? Now divide, let me write b square first here and divide this 4a square with this 4a square. So I have 1 here. Now let me write the minus sign as is. Now divide 4a square with let me write c as is, and 4a square to be divided with a. Then I will be having 4a, right? That's why I have written b square minus 4ac by 4a square here. Got it? Now I can say that x plus b by 2a whole square is b square minus 4ac divided by 4a square, right? Now let me take this power 2 to the other side so that it becomes square root on the other side, right? X plus b by 2a equal to square root of b square minus 4ac divided by 4a square, right? Now let us separate the root for both numerator and denominator separately. Let's write it. That way the numerator will be having square root of b square minus 4ac and denominator is 2a, right? You have square root of 4a square is plus or minus 2a. That's what we have written there. Now you have x plus b by 2a equal to plus or minus square root of b square minus 4ac divided by 2a, right? So we can further simplify this. For that, what I'm going to do is I'm going to transpose b by 2a from this side to the other side. When I do that, I can write the equation as x equal to minus b by 2a plus or minus square root of b square minus 4ac divided by 2a, right? Now look at this. The denominators are same. For that reason, what I can do is x equal to minus b plus or minus square root of b square minus 4ac divided by 2a, right? So this equation is called quadratic formula. If you are given a quadratic equation like ax square plus bx plus c equal to 0, roots of that particular equation are given by x equal to minus b plus or minus square root of b square minus 4ac divided by 2a. That's why, and this equation is called quadratic formula for finding roots of the quadratic equation. Fine? We just learnt about quadratic formula. Let's now find roots of 2x square plus 45x minus 47 equal to 0 using quadratic formula. You remember this particular equation is corresponding to Cocoa Code problem we have studied in the first video of this chapter, right? In the introduction video to quadratic equations, we have discussed about one problem, that is Cocoa Code problem. For that, we have derived the quadratic equation that is given as 2x square plus 45x minus 47 equal to 0. Now we want to find roots of this particular equation using quadratic formula, so that we can define what is the value of this x, right? Quadratic formula defines the roots for ax square plus bx plus c equal to 0 as x equal to minus b plus or minus square root of b square minus 4ac divided by 2a, right? Now let us compare 2x square plus 45x minus 47 equal to 0 with ax square plus bx plus c equal to 0. When you compare, you say that a equal to 2, right? That is the coefficient of x square. And b equal to 45, that is the coefficient of x. And c is the constant, that is equal to minus 47, right? Now let's substitute these three values into the quadratic formula. When you substitute, you write the equation as x equal to minus 45 plus or minus square root of 45 square minus 4 times 2 times minus 47 divided by 2 times 2, right? We have substituted a equal to 2, b equal to 45 and c equal to minus 47 into this equation, right? Now let us simplify this. This can be simplified and written as minus 45 plus or minus square root of 2025, that is 45 square. 45 square is 2025. And here you have 4 times 2, that is 8. 8 times minus 47 and times, here you have minus sign, right? Minus 8 times minus 47 is plus 376. Divided by 2 times 2 is 4, right? Now we can further simplify this and write it as minus 45 plus or minus square root of 2401 divided by 4, right? So square root of 2401 is equal to 49. So now x can be written as minus 45 plus or minus 49 divided by 4. When you look at this, you can say that x has two values. When you use plus symbol in between minus 45 and 49, you have one value. And when you use this minus symbol, you will have another value, right? Let us first consider plus symbol, so that I can write x equal to minus 45 plus 49 divided by 4, right? Minus 45 plus 49 is 4. 4 divided by 4 is 1. Now let us consider negative sign, so that I can write x equal to minus 45 minus 49 divided by 4, right? So the numerator is going to be minus 94 and the denominator is written as is, right? Now both are even numbers, so I can divide both the numbers with number 2, right? When I do that, it becomes 47 and it becomes 2, right? That's why I have written it as minus 47 by 2, that is equal to minus 23.5. Right? So now I can say that roots of the given quadratic equation are 1 and minus 23.5, right? But look at the figure. We are talking about cocoa coat and this length, right? Or length or width, whatever you call, right? We want to find that value of x. X cannot be a negative number, right? Length cannot be a negative number. For that reason, we say that x equal to 1 is the answer for this particular problem. X equal to 1 meter is the width of space around the court for spectators. If you remember, you are asked to place the court in a given rectangular enclosure such that you will have equal space for the spectators on equal width for the spectators on all the four sides of the court, right? So that is 1 meter here, if you remember. Otherwise, you go back to introduction video and take a look at this problem, right? Let us learn about nature of roots now. We have just seen that for ax square plus bx plus c equal to 0, the quadratic formula defines the roots as x equal to minus b plus or minus square root of b square minus 4ac divided by 2a, right? When you have this plus or minus symbol, it means that in one of the roots you will have plus symbol and in another root you will have minus symbol, right? That's why you can have two roots. Now we know that in ax square plus bx plus c equal to 0, the coefficients a, b and c are real numbers and a cannot be 0, right? A is not equal to 0. If a, b and c are real numbers, b square minus 4ac can be greater than 0, right? It can be equal to 0 or it can be less than 0, right? When I say that a, b and c are real numbers, b square minus 4ac, if you look at the value of b square minus 4ac, it can be greater than 0 or it can be equal to 0 or it can be less than 0, right? Now the question is, what is the nature of roots for all these cases? You know, how are the roots going to look when b square minus 4ac is equal to 0, or when b square minus 4ac is greater than 0, or when b square minus 4ac is less than 0? That is the question we have now, right? Let's try to understand that. Let us say that b square minus 4ac is greater than 0. Here I have already written that we get two distinct real roots, meaning you will get two roots, but they are distinct real numbers. That's what I have written here. Let's try to understand that. B square minus 4ac is greater than 0, right? B square minus 4ac is greater than 0 means it is a positive number, right? Let me define a positive number k. Square root of k, square root of positive number is another positive number, right? Let me define it as p, right? Now the first root, we said that minus b plus square root of b square minus 4ac, right? That is defined as p in this particular case by 2a is the first root, and the second root is minus b minus p divided by 2a, right? P is a real number, b is a real number, and a is a real number, right? For that reason you will have this as a real number, right? One root is real number and this root is also a real number, and these two are different because look at this, here I have plus sign and here I have minus sign, right? For that reason these two are distinct roots, are different roots, and they are both real numbers. You understood? When b square minus 4ac is greater than 0, we get two distinct real roots. Got it? And graphical representation of quadratic equation looks as one of the following. Meaning, when I said there will be two distinct real roots, the equation, the graph corresponding to the equation cuts the x-axis at two different locations. You see, in this case, both the roots are on the positive side of x-axis, right? Here, in this case, one is on positive side and one is on negative side. In this case, both the roots are on negative side. So one of these kind of thing is possible. Got it? As you see here, the curve is cutting the x-axis at two distinct points. Those 2 points are called roots. Please note this. When b square minus 4ac is greater than 0, the curve cuts the x-axis at two distinct points. That's why you have two different real roots. Understood? Now let us consider another case where b square minus 4ac is equal to 0. I said that the roots are real but they are equal. Let's understand this now. B square minus 4ac is 0, meaning square root of b square minus 4ac is also equal to 0, right? Square root of 0, that is equal to 0. Let's substitute that so that I can write the first root as minus b plus 0 divided by 2a, that is equal to minus b by 2a. And the second root is going to be minus b minus 0 divided by 2a, right? That is going to be minus b by 2a. Now look at this. Both the roots are equal, right? Minus b divided by 2a, right? And they are real because the numerator is minus b, that is a real number, and denominator is 2 times a, where a is real number, right? So when you have numerator and denominator as real numbers, the resultant is also a real number, right? For that reason, we say that roots are real, but they are equal. Understood? Now, the graphical representation of quadratic equation looks as one of the following. In this particular case, if you look at, the curve touches the x-axis at one point. Here also it touches x-axis at one point. Here also it touches at one point. In this case, it is touching at x equal to some negative number. Here it is touching when x equal to 0. And here it is touching when x equal to a positive number. Got it? So there is a possibility that you will have either negative number, 0, or positive number, real number, as the root of this particular equation. Got it? When b square minus 4ac is 0, the curve touches x-axis at only one point. Please note that is called root, and you have the same root twice. Got it? Now let's look at the third case. If b square minus 4ac is less than 0, then we said that roots are not real and they are imaginary roots. Let's understand this. When b square minus 4ac is less than 0, it means square root of b square minus 4ac is a negative number. Let me write it as minus k, square root of minus k, right? Square root of negative number is not defined. At least for you guys, it is not defined because you know only up to real numbers, right? You don't know about imaginary numbers or complex numbers, right? Those you will be learning in maybe next class. In the sense, you would be learning it in intermediate, right? So these are imaginary numbers, right? Those are not real numbers. For that reason, we say that when b square minus 4ac is less than 0, the roots are not real numbers. They are imaginary. In this case also, you will have two roots, but the roots are going to be imaginary roots. Since you are not exposed to imaginary numbers till now, we don't really worry about it, and we simply say that roots are not real numbers. In this particular case, the graphical representation looks like this. In all these cases, the curve is not touching x-axis, neither cutting the x-axis, right? In all these cases, when b square minus 4ac is less than 0, the curve neither touches the x-axis nor cuts through the x-axis. Please note this. When b square minus 4ac is less than 0, you have roots that are not real numbers and the curve doesn't touch the x-axis, right? Let us quickly recall what we have learned till now. We said that for ax square plus bx plus c equal to 0, the quadratic formula defines the roots as x equal to minus b plus or minus square root of b square minus 4ac divided by 2a, right? Here, for ax square plus bx plus c equal to 0 to become a quadratic equation, a, b and c are to be real numbers and a shouldn't be equal to 0, right? This is the requirement we have learned in the early lectures on this particular topic. And since these three are a, b, c are real numbers, there is a chance that b square minus 4ac, which is there under the root, can be greater than 0, right? You have a, b, c as real numbers, meaning b square minus 4ac is also going to be a real number, but it can be greater than 0. In that case, the roots are going to be two distinct real roots. The roots of the equation are going to be two distinct or two different real roots. When b square minus 4ac is equal to 0, we have seen that the roots are going to be real, but they are equal roots. Got it? When b square minus 4ac is less than 0, we learned that the equation will not have real roots. And we have said that the equation is going to have imaginary roots, right? But that is not part of our syllabus for 10th class. And the point here you have to note is, since value of b square minus 4ac is defining the nature of roots, in this particular case, whether it is greater than 0, equal to 0 or less than 0, the nature of the roots is differing, right? Here these are two distinct roots, real roots, and here real roots, but they are not different. And the third one, the roots are not real roots, right? So b square minus 4ac is defining the nature of roots, whether they are real roots or not. If they are real roots, are they equal? Are they different? Right? That's why we say that b square minus 4ac is discriminant of quadratic equation ax square plus bx plus c equal to 0. What is this? B square minus 4ac is the discriminant of quadratic equation ax square plus bx plus c equal to 0. Please note this. Now let's take a look at a problem. Find nature of roots of 2x square minus 4x plus 3 equal to 0. If real roots exist, find them. Now let us compare 2x square minus 4x plus 3 equal to 0 with ax square plus bx plus c equal to 0. So a is going to be equal to 2, b is going to be equal to minus 4, and c is equal to 3, right? Now, we know that b square minus 4ac is the discriminant of quadratic equation. Value of this is going to say whether real roots exist or not, right? So let's find the value of b square minus 4ac now. So b is minus 4, a is 2, and c is 3. Let's substitute that into b square minus 4ac so that I can write it as minus 4 whole square minus 4 times 2 times 3, right? Let us simplify this so that I can write it as 16 minus 24, that is equal to minus 8, right? B square minus 4ac is equal to minus 8. It means it is smaller than 0, right? Since b square minus 4ac is less than 0, we say that roots are not real numbers. So the question is, if real roots exist, we are asked to find them. But as you see here, you got b square minus 4ac equal to minus 8, that is less than 0. That's why you can say that real roots do not exist for this particular equation, right? Let me write that. Real roots do not exist for 2x square minus 4x plus 3 equal to 0, right? I hope you like the video. Please like, share and subscribe to our channel, Learn to Score. Thank you.